Hello children, how are you all? Hope you all are fine now and coping up with your chapters. I know children, it's very difficult during this time to go through the lessons all alone. We teachers are trying our best to reach you all. Previously children, what we had done, I had given you some PDF notes and all those things so that you can read the NCERT book many times as I have been telling you, then make your own notes. Yes, some of you have been asking me the doubts over my WhatsApp, but rest of the children, I'm not getting any response from them. I'm really worried about them. Children, now I have thought of one thing like I'll be sending you the notes in PDF, but which part I think it needs more attention. I'll try my best to give you some more details through videos. Not the usual ones, but I'll try as I teach in the class so that I can reach you. Let's see how far it is possible and how far this helps you. If you feel that this type of communication between us is beneficial, then we can do this way. Children, in previous classes, like in previous part in this chapter, metals and non-metals, I've given you some notes. The physical properties of metals. Now we'll be discussing certain chemical properties, and those parts also I have sent you. I'll try to send some small videos regarding some concepts, and I hope it will benefit you to some extent. Today we'll discuss chemical properties of metals, and that too today we'll be discussing reaction of metals with oxygen. Children, in your previous classes, in class 8, as far as I remember, I've shown you the reaction of magnesium, how it reacts with oxygen, that is on heating. Do you remember? When we burnt magnesium ribbon, what did you see? We saw that white fumes coming out from it. Is not it? I hope you remember that. Does it happen with all the metals we have known till now? Does oxygen react in similar way with all the metals? Let's see what happens. Children, certain metals like sodium and potassium, these are quite reactive metals. They react with oxygen vigorously. Okay. Vigorously in a sense, when it reacts with oxygen, it's an exothermic reaction and heat comes out, and what happens, it starts burning. So, these metals, potassium and sodium, they are always kept in kerosene to avoid direct contact with oxygen of water. Okay. If we go for, these are highly reactive metals. Certain metals are moderately reactive, like magnesium, calcium. All these are moderately reactive metals. Some highly reactive metals are sodium and potassium. Sodium and potassium reacts violently with oxygen. The equation becomes 4Na plus O2 will give rise to 2Na2O plus heat. A large amount of heat is produced from this. Okay. Actually, it is sodium plus oxygen is Na2O. On balancing the equation, 4Na plus O2 will give rise to 2Na2 plus 2Na2O plus heat. These are valent reaction. It reacts violently. Then comes calcium and magnesium. React moderately with oxygen, like Mg plus O2 will give rise to 2MgO. On balancing, 2Mg plus O2 will give rise to MgO. This is magnesium oxide. Similarly, calcium plus O2 will give rise to calcium oxide. Now there are certain other metals which react slowly. For example, iron, aluminium, copper react slowly. They have a slow reaction. For example, what we have, Fe plus O2 will give rise to Fe2O3. Okay, Fe2O3 means 2Fe plus 3O2. Children, when iron reacts with oxygen, it gives, if it Fe2O3, it is ferric oxide. And when we balance the equation, we have 2Fe plus 3O2 will give rise to Fe2O3, that is ferric oxide. Now, Fe3O4 is also one of the compounds and it is known as triferric tetraoxide. And if it is FeO, that is ferrous oxides. These are different oxides of iron. Now, when copper reacts with oxygen, what will happen, children? Cu plus O2 will give rise to CuO, cuprous oxide. Okay. Now, copper, this iron, aluminium, copper, this does not react with oxygen, normal oxygen at room temperature. What happens, you know, children? When you burn iron filings, this iron, when in form of iron filings or dust of iron, it is heated in presence of oxygen, then it reacts vigorously, it gives sparks. When copper is heated in presence of oxygen or heated in air, it will give copper oxide, which is black in color. What is the color? It gives a black color. Cu plus O2 will give you CuO, which is black in color. 2Cu plus O2 will give rise to 2CuO, which is the balanced equation. Children, what happens when aluminium reacts with oxygen? When aluminium reacts with oxygen, aluminium plus O2 will give rise to Al2O3. This is aluminium oxide. This is aluminium oxide. When we balance the equation, we will have 4Al plus 3O2 will give rise to 2Al2O3. This is aluminium oxide. Let me tell you one thing, children. Aluminium reacts with oxygen to give aluminium oxide. Copper reacts with oxygen to give copper oxide. Here iron reacts with oxygen to give iron oxide. Metals plus oxygen will give you metal oxides. But in our previous classes, in class 8, we have learned that oxides of metals are basic in nature. Okay. We had done one experiment, I hope you remember, that magnesium on burning in presence of oxygen used to get magnesium oxide. This fumes, white color fumes were coming out, and we got the ash, that is magnesium oxide. When we mixed with water and we tested with litmus paper, we got magnesium hydroxide, which is basic in nature. Metals in general, when reacts with oxygen, will give oxide which is basic in nature. And non-metals, oxides of non-metals are acidic in nature. But here one new thing we'll learn, that there are certain metals like aluminium, zinc, tin, lead. Aluminium, zinc, tin, lead. Oxides of these metals show both acidic and basic properties. Okay, children. Suppose oxides of zinc, oxide of aluminium Al2O3, oxide of zinc ZNO, oxide of tin SNO, strontium. Sn, we write Sn because of the Latin name is strontium. Oxides of lead PbO. Oxides of these are amphoteric in nature. Amphoteric in nature. They show both acidic property and basic property. One trick I'll let you know. Amphoteric. Ampho word means both. Like amphibians. You know amphibians? Amphibians can live in both land and water. Okay, both. Here also amphoteric means amphoteric oxides. Amphoteric oxides means they show dual behavior. They show acidic nature as well as basic nature. Now, these amphoteric oxides, let us take some equations. Al2O3, aluminium, Al2O3 plus HCl. Al2O3 is basic in nature. Suppose if it is basic, okay. When it reacts with an acid plus base, children, you remember, it gives salts and water. That is which reaction? Neutralization reaction. I hope you remember this. Now it will give 2AlCl3 plus 3H2O. On balancing, we get this type of equation. Aluminium oxide when reacts with hydrochloric acid, okay, it will give salts, aluminium chloride and water. This is a salt, aluminium chloride, okay, and water. This is what type of nature? Basic nature of aluminium oxide. Okay. Now, let's go for another example to see the acidic nature. Acidic nature means aluminium oxide when reacts with sodium hydroxide. This is a base. You know, children, sodium hydroxide is base and this is acidic. Suppose here you consider the acidic nature of aluminium oxide. Aluminium oxide plus sodium hydroxide will give you this is a salt and its name is sodium aluminate. NaAlO3. Al2O3 plus 2NaOH will give rise to 2NaAlO3 plus H2O. This is known as sodium aluminate. It's important, children. It's important reaction. Similarly, you can go for reactions with zinc, lead and tin. Generally, one more thing, generally oxides of metal are not soluble in water, but oxides of sodium and potassium are water soluble, and these are known as alkali metals, and these are called alkali metals. Alkali metals na sodium in its solid form, sodium oxide in its solid form plus water will give rise to NaOH. What is this? Aqueous sodium hydroxide. Aqueous means insoluble in water. Similarly, potassium oxide plus water. This is liquid. Water, L means liquid, will give rise to 2KOH, and this is aqueous. I hope, children, now you have understood. So, as we have known, some metals, they are soluble in water and forms alkalis. Okay, and they are sodium and potassium. They form water soluble. They are oxides, and they form hydroxides, like sodium when reacts with water. Sodium oxide when reacts with water forms sodium hydroxide. Potassium oxide when reacts with water, it forms potassium hydroxide, which are soluble in water. We'll discuss one more thing. As you have seen, children, when we try to burn magnesium ribbon, you might remember, at first when we ignite it or try to burn it, it doesn't burn. What is the reason? Can you guess? We had discussed. I hope you have forgotten, or if you remember, magnesium forms a layer of oxide over it. Okay, when we try to burn it, it doesn't burn instantly. So what do? We take a sandpaper, we rub the surface of magnesium, then we burn it, and then it burns vigorously with white fumes and gives ash of magnesium. This coating on magnesium is actually, it is a coating of oxide. Oxide means it reacts with the atmospheric oxygen to form magnesium oxide, a layer of magnesium oxide, and it's a very slow reaction. Similarly, when we rub it with sandpaper, what happens? We remove that layer of magnesium oxide, then try to burn it. Or similarly, things happen for aluminium and zinc also. You might have seen, children, when you go to shop and buy some aluminium utensils. All of you might have experienced. We bring home very dazzling utensils. When it is new, it's very dazzling. But overuse, or when we keep it for some time, after some days, what you see? Some blackish color appear on that. What is that? That is a coating of atmospheric oxygen, but it's a slow process. Children, similarly, in case of aluminium utensils also, after some time you see that some blackish covering is there. It becomes, the shining goes away and becomes little blackish. What is that? It is the coating of aluminium oxide because it had been reacting with the atmospheric oxygen, although it's a very slow process. Okay. But children, let me tell you one thing. In case of aluminium utensils, this becomes beneficial for them. Why beneficial? Once they get the coating of aluminium oxide over it, this coating of aluminium oxide on these utensils prevent further corrosion. Means the reaction slows down with oxygen and it doesn't get much more black. You might have experienced that. After reusing for several years also, it doesn't get spoiled and it prevents corrosion. Similarly, so nowadays children, a new method has come out, that is anodizing the utensils. Okay, what is anodizing? Anodizing. What is that anodizing? Nowadays, what happens? People have come out with certain new type of utensils known as anodized utensils. The aluminium utensils which are anodized. Anodized means they are covered with thick layer of aluminium oxide which prevents further corrosion. You can see these type of, I'm showing you a pan. This is not non-stick pan. Okay, this is not non-stick pan. It's not a coating. Non-stick pan has a coating of Teflon. You have known that. But this is aluminium, but it is anodized. Anodized means thick layer of aluminium oxide is there on it, which prevents corrosion. It doesn't become black. As in other work or these things, you find it become blackish on for repeated use. How this anodizing is done, let me explain you. Anodizing means process of forming thick oxide layer of aluminium As we know, aluminium forms layer of aluminium oxide when exposed to air. If the coating of aluminium oxide is made thicker, then it can't prevent corrosion to a large extent. How this is done, let me tell you. Here, the aluminium utensil is taken as anode in the process of electrolysis. You remember the process of electrolysis? Okay, we have anode and cathode, two electrodes, anode and cathode. Since this is connected to the negative end, this is cathode and this is anode. And here we put the electrolyte. Here dilute sulfuric acid is taken as the electrolyte. Dilute sulfuric acid is taken as the electrolyte. In the process of electrolysis, as you remember, what happens when we switch on the key? Current starts flowing in the circuit. And here in the anode, you are taking the utensil over here. Okay? And on electrolysis, you will get oxygen gas is produced at anode. On electrolysis of sulfuric acid, you get oxygen at anode and hydrogen gas at cathode. So hydrogen gas is liberated through cathode and oxygen is coated over anode, which is taken utensil, which is here in the anode we have taken the utensil which is to be anodized. Okay, so on getting thick layer of oxygen or thick layer, here it forms anodized vessel which is corrosion resistant. This is through the process of electrolysis they make anodized vessels, and this is how anodizing takes place. Means thick layer of aluminum oxide is formed over here. Okay, on repeated reaction with oxygen. The oxide layer easily to give aluminum vessel an attractive look. So children, give importance to anodizing. It's an important concept. You have to remember this. Let me repeat. Anodizing is the process of forming thick oxide layer of aluminum. Okay. How this is done? This is done through the process of electrolysis. The utensil or the article which is to be anodized is taken as anode, and electrolyte used is dilute sulfuric acid. On electrolysis, it gives hydrogen gas and oxygen gas. Oxygen gas is liberated at anode and hydrogen gas is liberated at the cathode. Oxygen gas reacts with the aluminum vessel, container, utensil, article, whatever it is, and they form a thick layer over it. This layer can be dyed easily and it gives an attractive look to the utensil or the article, and it prevents corrosion also. Okay, this is an important concept. Try to learn it and make proper notes of it. I have sent you those things. You make it. You can read the NCERT book for this also. Okay. Our conclusion is, certain metals reacts vigorously with oxygen, certain metals reacts moderately with oxygen, and some metals react slowly with oxygen. Okay. Vigorous are, you remember, sodium and potassium. Moderate, magnesium, calcium. Slow are aluminium, zinc, copper. Copper gives, when burning with oxygen, when burns in presence of oxygen, it gives a black color and anodized. So, first try to go through the equations and remember them, practice them. In the next video, we'll discuss about reaction of metals with water. Okay, bye children, take care.